In this video, we will try to understand what is call by reference and call by value in JavaScript. So to understand this, you need to have a prerequisites. You need to have basic knowledge about JavaScript, and you should know what are arrays and what are basic data types in JavaScript. So let's get into the video. So here I just created an empty file, and here I'm going to write the code. So basically, before we understand what is call by reference and call by value, firstly we need to know the type of data types. Like we know number data type, and then string data type, object data type, array data type, etc. Right? So here we divide those data types into two units. One is primitive data type, and we also call this as simple data types. Okay, and the other one is non-primitive data type, and this one we call as complex data types. So basically all the data types are divided into two units. One is simple data types or primitive data types, and the other one is non-primitive data types, or we call it as complex data types as well. So let me tell you what are primitive data types in JavaScript. Some examples, like number is a primitive data type, string is a primitive data type. Coming to non-primitive data type, in non-primitive data type only objects, all objects are non-primitive data types. So if you remember, array is also the object data type in JavaScript. Okay, so objects comes under non-primitive, and then the number, string, and etc. will come under the primitive data types. Now basically the storage of this primitive and non-primitive data type in the call stack or in the memory will be dependent on which data type, which unit it belongs to. If it is a primitive data type, it will be stored in some way, and if it is a non-primitive data type, it will be stored in some other way. So we need to understand that one first. Okay, so I'll just create a variable a, which is a primitive, which is 20. I'll create a function, and in the function name is test, just like this, and it's going to take a parameter x, and it's going to update the x by 1. Okay, and then here I'll be calling test function by passing a. Okay, a means basically 20 I'll be passing, and then here I'll be just logging that a. So let's try to analyze this, how it is going to behave, and then we will save and see the output. So basically what will happen in the call stack first. So let's assume this is our call stack. So this is our call stack, and at the very bottommost, global execution context will be created, and the execution starts from line number 6. So line number 6 is in global, so a will be declared with a value of 20. The control moves on to line number 7. So line number 7 is a declaration of a function test. So it's a function. Control jumps from line number 7 to line number 10, and at line number 10 we are calling the function test. So test invocation it is. So what will happen, another brand new context will be created, which is test execution context, and in the text execution context, the control from line we are actually passing a here. So while calling this function test, we are passing a, that means we are passing 20. So 20 we are passing, so 20 will be captured by the x parameter within this context, right? When the control jumps to line number 8, here I say x equal to x plus 1. That means what will happen, this 20 will be updated to 21, and you see here this x is a local variable to this function execution context, and this has no relation with its a value, whatever we passed. So here when we passed a, it will actually, the 20, the value that a contains, will be passed to the function, because it's a primitive data type. So whenever we encounter with passing some data into a function, if it is getting a data from some other function, if it is a primitive, the value will be passed. Okay, so here 20 value is passed directly, and the 20 value is captured by x, and then when we updated x within this context, x will get updated to 21, and it does not affect the original variable, which is a. And this thing we call as call by value, because we are calling the function by passing the value directly. We are passing 20, which is a value. Okay, and what will happen when I update x here. So here also I'd like to print a statement saying that x. So what would be the x value? It would be 21, because within this function context, when line number 9 gets executed, So x will get updated to 21, so 21 will be printed at this line. And once this function is done, what will happen? So this will be erased from the call stack, and the control comes out to back to the global execution context. And in the global execution, we are done with this line, and the control moves to line number 12. So when we print a variable at line number 12, so in the global, when we print variable a here, so we have to look for that variable within this context. Yes, the variable is there and the value is 20. So at this place, what will be printed? 20 will be printed. So let's see the output, and you see 21 is printed inside this function, which is the x value. So internally within this function, the value got updated, but it didn't affect the actual variable a that we passed as an argument for this function call. And then when we come out, the original variable which is in the global context is as it is. Okay, and this thing we call as call by value. So you will understand the meaning of call by value very clearly when you understand call by reference. Now let's see what is call by reference. Call by reference. So before we actually understand call by reference, I just wanted to have a tricky question over here, little small question. So let's say I'll create a variable a, and it's going to hold 2 elements, 1 2 3 elements like this. Okay, and the data type of a, we know what is the data type of a. It's an object. That means it's a non-primitive. Okay, and I told you the storage of data will depend on which type it is, whether if it is non-primitive or primitive. If it is primitive, then the data will be going to store directly in the stack memory. Otherwise, it's going to be stored in some other place that we will discuss now. Okay, and now here I'll create another variable b, and then I will assign a to it. I'll just update b of 0 to be something like 99, and then I'll log a of 0 and then b of 0. So if you make an analysis for this, what we will do is simply here, if you make the analysis for the small code, so here a is been assigned with a value of array 1 2 3, and when I create b and assign a to it, of course b is going to get this value 1 2 and 3. And here at line number 20, what I'm doing, I'm updating b of 0. So b of 0, when I update, what will be the b? So b will become something like 99 and then 2 and then 3. So b is updated to a new array, right? And a was not updated anywhere, so a will be as it is. So here when I print a of 0, so it should be 1, and when I print b of 0, it should be 99. So this is what we expect. But let me save and show you. Unfortunately, the expected answer is wrong, that we were expecting it to be 1 and 99, but it is not 1 and 99. Instead it is 2 99s. Okay, so this is very straightforward. To understand it, firstly you need to know how the data is going to be stored in the memory when it comes to non-primitive case. Then we can answer why it is behaving so. Okay, so let's try to go through that. So here I'll just create the call stack again. So this is our call stack, right? So when we run the program, what will happen? Global execution context will be created at the very bottom most, right? And then the execution starts from line number 18. So at line number 18, what we did, so there is a variable declaration which is a. So there is a variable declaration which is a, and the value of a is what? So a will be declared within global execution context, and the value of a is 1 2 3. So here is the thing that we need to change. Actually, like the primitive variables, so when I assigned a 20 value or a 30 value or a string value, they will be assigned to the variables directly within the stack. Okay, but in case of non-primitive, now this is an array or this is an object, so which will not be stored in the stack itself, but instead it will be stored in some part of the memory called heap. So let me tell you that thing. So the array will not be stored in the stack directly. So A is not going to hold that array directly, but there is a part of memory which we call as heap memory, which is compared to be little big, not little, much big than the stack memory. So here is the heap memory comes. And then in the heap memory, so since I told you Non-primitive data type is a complex data type which can store huge amount of data. Like an array can store millions of numbers, which is very huge, right? As I told you, stack memory is comparatively much smaller than the heap memory. So stack memory is not there to hold that big data. So that's why we use the heap memory for storing the complex data, which is non-primitive data. So the array 1 to 3, even though it holds 3 numbers only, but still it's a non-primitive, which will not be stored in the stack, but instead it will be stored in the heap. So in the heap at some place, the array 1 to 3 will be stored. Okay, and 1 to 3 is stored over here. But how do this A knows that its values are 1 to 3? So basically in the heap, for every memory byte, there is an address allocated for it. So this 1 to 3 will occupy some amount of, let's say, 12 bytes of memory. Let's say from address 20, each address will hold a single byte. From address 20, 21 and up to 27, which is 8 bytes, and then I'll make it to 31, let's say, which will make it to 12 bytes. So from 20 to 31 it will be 12 bytes, right? So these three numbers, let's assume these three numbers are stored from the memory address 20 to 31. So that means whenever we wanted to capture an element in any memory, we need to focus on the starting memory address of that. So here the starting memory address for this contiguous array would be 20. So when we have this reference, instead of storing this complex data, which is 12 bytes of data directly in the stack, we can just store the reference of the data which is stored in the heap, right? So that would make much efficient to use the stack memory. So the variable A, instead of holding the all 12 bytes together, it will just hold the address, starting address of that contiguous memory wherever the array is stored in the heap memory. So A will going to hold this address 20, and here I use a hash in front of it just to indicate that it's an address, just not to avoid confusion between numbers and addresses. So these addresses are numbers only, but these are different from regular numbers. Okay, so when I say A equal to 20, that is different from A equal to hash 20. So hash is just my own notation to indicate that it's a memory address. So now A has a reference of this array. So since A has a reference, that means it's pointing to this address, so it can decode the data that's present in the entire 12 bytes of memory. So this is how a variable can utilize this 12 bytes of memory to access the data inside this 12 bytes. Okay, so this is how basically the non-primitive data will be stored in the heap memory, and then the reference of that will be captured by the actual variables which are in the stack memory. Okay, I hope you understand this. So let's move forward. Now we are done with line number 18 and coming to line number 19. So line number 19 is also present in the global, and here I declare a variable B, and the B variable is going to hold a value called A. So what is A value? Just look at it. A value is 20. Is it just the 20? Of course not. It's the hash 20. That means it's an address. A is holding an address. And remember, when you log A, you won't be printed with these addresses just for some reason, but you will be printed the data in that address. Okay, so just for the conceptual understanding purpose, I am showing all this. But when you log A, you won't be printed with this hash 20 or some other address. Okay, but you will be printed the data inside that address, right? So now for variable B, we assigned variable A. That means we are assigning the same address, which is 20. Right, now B and A both are holding the same address. That means both are pointing to the same memory location, right? And then coming to line number 20. So at line number 20, B of 0 equal to something. That means B of 0 means at address 20 the data is there, right? 12 bytes of data. So B of 0 will point to the first 4 bytes, which is the number 1, and that first 4 bytes we are updating with 99. So the number 1 will be updated with 99. So it will be no more 1 2 3. Now it is 99, 2 and then 3. The data is 99 and 2 and 3, where it address 20. Okay, using the reference of B, we manipulated the address. And when control jumps to line number 21, here we are printing A of 0 and B of 0. Now you see, what is A? A is referring to address 20. At address 20, what is A of 0? It's 99. So A of 0 should be 99, right? And similarly, what is B of 0? So B is referring to address 20. So B of 0 means in that 12 bytes of memory, it will grab that first 4 bytes, which is again 99. So this is the reason why we were printed with 299s instead of 1999. Why? Because the non-primitive data will not be stored in the stack memory as we expected, but instead it will be stored in the heap memory, and the reference of that storage will be captured by the actual variables present in the call stack. Okay, I hope you understand this little bit theory, and if you understand, then we can move on forward. And before that, let me save, and this is already saved, so you see that the output is 299s. Let me comment it. And then now coming to another scenario I wanted to discuss. So let's say I'll create a function called call, and this function is going to take some variable x, and here x of 1, let's assume x is an array, so x of 1 I'll make it to 99, and meanwhile it also takes y variable, and y I'll make it to some string which is my name. Okay, and then outside this function I will call this function by passing some data. So let me create some a variable which is 4, 8 and then 7. A is an array, b is another variable which is 33. Okay, now you see b is the primitive data type and a is the non-primitive data type. Now I'll pass a as the first argument and then b as the second argument for this call function, and then immediately after that I'll just log a and then b. So I'm going to just log a and b after making the call, and then here also inside I'm going to log x and then y. So before we save and see the actual output, let's try to analyze using the concepts that we know till now, like primitive data will be stored in the stack and then non-primitive data will be stored in the heap. Let's use that principle to answer this question and what's the output. So firstly we need to draw the call stack just like this, and since non-primitive data is also included, we will be using the heap memory as well. Okay, and this is call stack. So firstly, at the very bottommost in the call stack, what will happen? Global execution context will be created, and then the execution starts from line number 24. So at line number 24, that's a function declaration. So call is a variable which will hold a function value, and then the control jumps from line number 24 to 29. So at 29 you see a is declared, and you see the value of a is not a primitive, it's a non-primitive. So where that will be stored? It will be stored in the heap, right? So let me make it to 4, 8 and 7, just like this. So let's say the address of this is 200. I'm just assuming the address is 200. So a will capture the address 200 here. So I'm keeping a hash in front of it just to indicate that a is holding the reference of this data. Okay, and now b is also created. So b variable is going to hold the value 33. So it's a primitive, so directly it will be saved within the stack only. And then coming to when the control moves on to line number 30. So at line number 30 you see we are calling the function. So when we call the function, there is a pause and a brand new context which is call execution context got created, right? And in the call execution context we are actually passing two arguments to it. One is a and b. So when a is passed, a will be passed, which is its reference will be passed, basically the value present in a, which is hash 200. And who is there to capture that a? Here x. So let me make it to x. And then b is 33, so which is passed, and I told you b will be, when we pass primitive, the value of it is directly passed, which is 33. So y will capture the value 33. So it is just a number and it's the reference. Okay, that's why to avoid the confusion I made a hash in front of 200. Now since it's a call, so the control jumps inside line number 25 after capturing the arguments, and you see x of 1 equal to 99. Now what is x? X is not something, it's a string or something else, but it's a non-primitive. It's holding a reference. That means it's a non-primitive. So x of 1 means at this address 200 in the heap memory, the second element was 8, right? So that 8 we are updating to 99. that 8 we are updating to 99. So that's what x of 1 equal to 99 is. So that means basically at this particular instance, the x in the call execution context and the variable a in the global execution context, both are pointing to the same address at this instance of time, right? That means both of them can manipulate the data inside that address. And once this line is done, the control moves to line number 26, and here we update variable y with another primitive value. And Arvind is a string, right? So the variable 33, which is present inside y variable, will be assigned with a string value. And I told you string is a primitive, so it will also be there here itself. So Arvind string also be stored within the stack, which is into the variable y. And when the control jumps to line number 27, so when we print x and y here, so x is pointing to address 200, so it will print the entire array, which is 4, 99 and 7. And when I print y will be printing this Arvind. So let me write that x will be 4, 99 and then 7, because it was pointing to a hash 200 address, and then y will be printing this Arvind string, right? And once that is done, then the control moves to line number 29, which is the closing brace. That means that's the end of the function. So what we should do, we should just erase this context just like this. And once it is done, we will get back to the global execution context. And in the global execution context, wherever we pause, there will be a play again, and the control jumps to next line, to line number 32. And at line number 32, we are printing a and b. And line number 32 is strictly present inside global execution context. So we are printing a and b. That means a and b will be set within global execution context. So what is the value of a? It's a reference. So will the reference be printed? No. The value at that reference be printed. So what is the value at reference 200? It's 4, 99 and 7. So 4, 99 and 7. And coming to what is b? So b, the variable b in the global execution context is holding a primitive value, which is 33. So b will be printed as 33 only. So this is what the expected output based on the concepts that we know, and it would be the exact output as well. So let me save it. And you see at line number 27, basically at this point you see 4, 99, 7 and then Arvind. So you see that the array is 4, 99 and 7, and then the string is Arvind. Okay, and then at line number 32, so you see when I printed a and b, the array is 4, 99 and 7, and the value of b is 33. Now here I wanted to tell you one thing, the final summary of this video. So if you observe, when I passed a, I was passing the reference of a. Like a was, a is holding the non-primitive, right? So that means a actually holds a reference of this non-primitive data. So here I'll be much like, calling this function by passing hash 200 and then the 33 value. Okay, so the first pass value is a reference and the second value is just a value, number value. Okay, so the variable x parameter will capture the reference, which is 200, and then the y variable will capture the 33 value. So when I updated y within this function, y is got updated within this function, and when I updated x within this function, so at address 200 indirectly I manipulated, so eventually it's going to show effect on this address as well. Okay, and when I printed here after coming out of the function, so you see a is got manipulated exactly what we did inside, whereas b is not manipulated because b we just passed a value, a copy of b value we passed here, which is 33, copy of value, whereas a we passed the reference, so that the one whoever captures that reference inside that function can also have the control at that heap address, so it can manipulate that. And here we say that variable a is passed by reference. So this first one is calling the function by passing the reference, and the second argument is passed by value. So that's what passed by value and then passed by references. So a is passed by reference and b is passed by the value. I hope you understand this. In the next video we will see some more things. If you do like the video, please do subscribe to the channel. Thank you.